My name is Marcio Carzino, and I am a student of postgraduate in Federal University of Paraná State. I did this work with my advisors, Marcelo Herrera and Jorge Stanesco. In this study, my work presents a geometric study and multiphysical simulation between different wafers baking plates. Wafer are biscuits baked under pressure and intense and fast heat. There are different types of wafers with specific characteristics such as cones, hollow wafers, rolls, among others. The objective of this study is to analyze the influence of fins on the heat flow through the baking plates. New fins, shapes, homogeneous baking temperature, and possible weight reduction of the baking plate and consequently moving power, reduce the gas consumption, save electrical energy, and goal to provide better access of the heat from the burners to the surface baking plate. The oven works in this design with batter depositing in the beginning of the oven, and the liquid batter is deposited on the baking plates through the oven in a baking cycle, goes to the end and back to the front cabinet where the baking plates are open and the wafer sheets are released. Then, in the beginning of the oven, the liquid batter is deposited in the baking plate. Here we have a picture of 3 baking plates and 5 burners simulated at softer, and the profile temperature on this right side is the temperature. And the motivation is reduce the gas consumption, reduce the electrical energy, and because 1 kilo of wafer emits 0.053 kilos of carbon dioxide. This slide shows the electrical circuit and thermal circuit between emission of the radiation burner and conduction from the baking plates, the top and lower baking plate, and the heating comes out by convection from the mass of the wafer that is baked between them. The assumptions for this development of the physical and mathematical model are a stationary state, diffuse radiation is predominant mechanism of the heat transfer. We don't lose heating for surroundings. The flows and the pressure is constant, and the liquid batter deposited on the baking plate is the scaling of a boiling water heating transfer coefficient by the similar characteristics. The ambient temperature of the oven is considered stable around 150 degrees, and the flames are considered a form continuous radiant surface that produces a heat flux around 20 kilowatts per square meter. The emissivity of the flame is set to 0.23. This temperature field by conduction in the cast iron baking plate. We consider an energy balance of heat transfer by modes by conduction, convection, and radiation. And the radiation by the burners are related to back area of the plates and the view factor between burners and the plate and the radiosity between burners and plate. The view factor is the radiation leaving the burner and hitting the plate shared by total radiation leaving the burner. The radiosity of the plate also can be calculated by emissivity of the cast iron, emissive power, and total irradiation on the plate. The emissive power of the baking plate is defined by Stefan Boltzmann law, and the difference between temperatures of the plates and the burners on the fourth power. Here, this slide shows a normal mesh applied on simulation and isothermal contour lines in a pyramidal profile with 15 fins. And this slide shows the radiosity profile calculated by console software, and the temperature data is exported to a spreadsheet. The constructor design was used to provide a solution for this study, and we developed a formula to calculate the constant volume with aleatory conditions and parameters. These parameters calculated by a nonlinear algebraic solver was used to design each type of geometry of the plates, from 3 to 17 rows of fins. Also, the deformation of the plate by high pressure of baking must be adequate to produce good wafers. The plate deformation is given by the equation here. And the inertia moment and deformation is calculated by console software. The results shows that more fins transfer more heat to the baking plate. The measure of the temperature of the plates in a oven working with a thermographic camera and the temperature of the baking plates are similar to temperature provided by flat radiation burners becomes valid the computational simulation. These pictures shows triangular, rectangular, trapezoidal, contruncated, pyramidal, and hexaedron fins simulated in the software with the mesh. And this graphic show a temperature profile along the width of the baking surface of the plate for trapezoidal shape from 3 to 17 fins. Here the triangular, rectangular, parabolic fins, pyramidal, hexaedron, and truncated cones. The truncated cones fins are results as like for pyramidal also shows a straight line resulting in a constant temperature in the baking surface, and this is good. This graphic in this slide shows the average temperature increasing with the number of the fins for all geometries, increasing the geometries, the temperature. This results is the difference between higher and lower temperature appears in a graphic showing the better results for pyramidal and truncated cone. The deformation of the plate due to the baking pressure also is lower for pyramidal and truncated cones. And the final graphic show the better designs for construction of the baking plate with higher and constant temperatures and lower deformation. Then we show the better designs. The conclusions are the results point to construct baking plates with truncated cones and pyramidal fins. By deformation, higher and constant temperature of the plates. Higher temperature can reduce the gas consumption. Constant temperature can provide homogeneous coloring and humidity of the wafer sheets, and lower deformation means we can do a plate with less material. The position of the burner can have a big influence in the baking plate surface and the distribution of the temperature on this surface. The next steps is simulate other burners position, simulate transient state, simulate the baking of the batter on surface, and provide a physical model and test in an existing oven. Such simulations require more effort and computational processing capacity. Thank you.